Shift microoperations are used in order to shift the data within a given register. Here we have an example for R2, register R2, which holds the value of 1100 1001, as you can see over here. Then after the operation, the shift operations that we have here, we can have a look at the content of R2 again. The first operation to consider is the shift left, this operation here. We want to see what happens to the content of R2 when we perform the shift left operation once. You can see how the symbolic designation is for shift left, SL. SL stands for shift left. Then we specify the name of the register in front of it with a space, and then the result will be copied into R1. So what do we have for R2? R2 contains 11001001. We want to perform the shift left. In this case, the direction of the shifting will be like this, from right towards the left. So 1 will be copied here, 0 will be copied here, and we will have 1 going out. As a result, after performing the shifting, we will have 1 0 0 1 0 0 1, and for the least significant bit we will have a 0 inserted. Over here we call it the zero field, because the new data that we enter into our register is 0. It could be anything if we want to, so it depends on how we design, how we implement the shift operation. By default, we insert a 0 to fill the empty, let's say the empty bit, but we could also specify a bit from a given register in order to fill it. On the other hand, we can have the shift right. The instruction is SR shift right. We shift right the content of R2 and then copy the result into R1. Again, we have R2 here, 11001001. If we shift the content of R2 by one bit position towards the right, so 1 will be copied here, 1 will move here, 0 will move here, and so on and so forth, and 1 will go out. And the new data that we enter into our register will be by default 0. So 0, then 1 1 0 0 1 0 0. This will be the result of shifting the content of R2 by one bit position towards the right, and then it will be copied into the register R1.